Okay, so Assalamualaikum warahmatullahi wabarakatuh. Good morning, good afternoon, good evening. And should I say good night? Never mind. Okay, so this is the second set. So let us start with question number 1a. So this is the limit of x approaches -1 for x plus 1 over 3x squared plus 8x plus with 5. Okay, so if we do try to substitute x with -1, we are going to get -1 plus 1, which is equal to 0. 3 times -1 square, so this one will give us positive 3, positive 5, so 8 then minus 8, so that is also 0. So if I do try to substitute with x equal to -1, I'm going to get 0 over 0. So it means that I must either factorize them or I can multiply with the conjugate. So I don't see anything with a set, so let me factorize my denominator. Okay, so let us factorize that. So this is the limit as x approaches -1 for x plus 1 over, so factorizing the denominator, so we got 3x, x, perhaps this is 5, 1, so 5x, 3x plus, so 3x plus 5, x plus 1. And then of course you should be able to cancel out x plus 1 and x plus 1 now. So we will be left with the limit as x approaches -1 for 1 over 3x plus 5. So substitute x with -1, so we are going to get 3 times -1, which is -3 plus with 5, so it will become 1 over 2. Okay, so done with question number 1a, so let us proceed with question number 1b. So like usual, let me group this one first before we do question number 1b. Okay, so now number 1b, so we need to find the limit as x approaches 5 of the square root x plus 4 minus 3 over x minus 5. Okay, so now let us see what happened if we do try to substitute x with 5. So we got 5 plus 4, which is 9, so set of 9, so this one will give us 3, 3 minus 3, so therefore we have a 0. 5 minus 5, that will also give us a 0. So basically in our numerator, we are going to get 0. In our denominator, we are also going to get a 0. Okay, so what happened is that we must either factorize or multiply with the conjugate. So I do see something with a set in my numerator, so I'm going to multiply with the conjugate of my numerator. Okay, so this is equal to the limit as x approaches 5 of square root of x plus 4 minus with 3 over x minus 5 multiply with square root of x plus 4 plus 3 over square root of x plus 4 plus 3. Okay, so now let us multiply them first. So this is the limit as x approaches 5. So set times set, so we are going to be left with x plus 4, -3, positive 3, so it will become -9 over x minus 5 square root of x plus 4 plus with 3. Okay, so basically if you times with its own conjugate, for example our numerator over here, so we are multiplying between the conjugate, so we're going to expand them. If we don't have anything with the conjugate, so we're going to leave them in the bracket just like what we did in our denominator. Okay, so let me simplify our numerator. So this is the limit for x approaches 5, x minus 5 over x minus 5, and then the square root of x plus 4 plus 3. So cancel out, and we are left with the limit of x approaches 5, 1 over the square root of x plus 4 plus 3. So now do try to substitute x with 5. So we are going to get 5 plus 9 plus 5 plus 4. Tersasa. The square root of 5 plus 4, which is square root of 9, so 3. 3 plus 3, that will be equal to 6. So this one will be 1 over 6. Okay, so done with number 1b. Okay, so now question number 1c. So we need to find the limit as x approaches positive infinity of 2x plus 1 over the square root of x square minus 9. Okay, so again, if you do try to substitute with infinity, you are going to get infinity over infinity. So if we have infinity over infinity, this is actually indeterminate form. So we need to divide with the highest power of denominator. So we divide with, so in our denominator, we actually have x square, but x square is actually inside a set. So this is actually x to the power of 1, because x square inside a set is simply x to the power of 1. So I'm going to divide my numerator with x and my denominator with x as well. So this is equal to the limit as x approaches positive infinity to x plus 1 over x over the square root of x square minus 9 over x. Okay, so basically in my numerator, that is fine because I have them in the same form, so I can actually divide them quite easily. But in my denominator, I don't have them in the same form sebab atas ada set, bawah tak ada set. So I'm going to modify them a little bit. So this one I'm going to do a square as well as a square root of them. So they're positive of infinity, so this is positive as well. If we are going to negative infinity, so I need to put a negative. Okay, so what happened now is that this one gonna become the limit as x approaches positive infinity of 2 plus 1 over x over the square root of, so x square over x square is 1 minus 9 over x square. And then you do know, using the property 1 over infinity is equal to 0, 9 over infinity, that is also equal to 0. So what do we end up is actually 2 plus 0 over square root of 1 minus 0, which is simply equal to 2. Okay, so done with this part. So let us proceed to question number 2. Okay, so question number 2a. Okay, so differentiate with respect to x and simplify your answers. Okay, so let me see. So we got y equal to e to the power of 5x over 1 plus e to the power of 2x. Okay, so we're going to differentiate them. Obviously, this is a fraction, right? So that means we need to use a quotient rule. So one of them will become a u, so definitely on top will be a u. The bottom will be a v, so v u prime minus u v prime over v square. So we're going to use the quotient rule for them. Okay, so dy over dx. Okay, so v first. V is 1 plus ex, e to the power of 2x. U prime differentiating e to the power of 5x. So it will become 5 e to the power of 5x. Okay, so when we differentiate e to the power of 5x, so we're going to copy down the exponent first, e to the power of 5x, and then we're going to differentiate the power, so that is how I get a 5 over there, and then minus with a u, e to the power of 5x, and then we have to differentiate 1 plus e to the power of 2x. So I don't think I have enough space, so I got to move this one. Okay, so differentiating 1 plus e to the power of 2x. So differentiate 1, it will become a constant. Differentiate e to the power of 2x. Again, copy down the exponent first. Differentiate the power, so you will have 2. Divided with our v square, so 1 plus e to x to the power of 2. Okay, so now let us simplify our numerator. 1 times 5, so this is 5e to the power of 5x. E to the power of 2x, 5e, 5x. So plus with 5e to the power of 7x minus, so e 5x, e 2x, so e to the power of 7x times with 2, so negative 2 then. Okay, so everything over 1 plus e 2x square. Okay, so I'm gonna simplify them. So I have 5e 5x, and then 5 minus 2, that one will become 3 e 7x over 1 plus e 2x square. Okay, so whenever we want to factorize, normally we have to see first which one that has the lowest index. Okay, so if you compare between e to the power of 5x and e to the power of 7x, obviously e to the power of 5x is the lowest, so you can actually factorize e to the power of 5x, and then you will have 5 plus 3e to the power of 2x over 1 plus e to the power of 2x with a square. Okay, so done with question number 2a. So let us proceed to B. Okay, so number 2b, I have y equal to ln of x cubed together with the square root of 2x squared minus 1. Okay, so we're gonna use the formula for this first. Okay, so if let's say we need to differentiate ln of something, so that is equal to 1 of something, and then we need to differentiate that thing. Okay, so let me do the same thing over here. So dy over dx will be equal to 1 over x cubed square root of 2x squared minus 1, and then of course you need to differentiate x cubed and the square root of 2x squared minus 1. So sekejap, nak kena adjust sikit. So 2x squared minus 1. Okay, so basically on the left hand side this is okay, so x 1 over x squared 2x square root of 2x squared minus 1, so yang sebelah sini okay. We just need to differentiate x cubed square root of 2x squared minus 1. So obviously you need to use a product rule for this. So one of them is a u, another one is a v, so we're gonna use the product rule. Okay, so u is equal to x cubed, so u prime differentiating x cubed will be 3x squared. V is equal to 2x squared minus 1 to the power of half. So v prime, bring down the power first, copy down the function, but deduct 1 to the power, so it will become negative half. Differentiating 2x squared minus 1, so it will become 4x. So what do we have left is 2x over the square root of 2x squared minus 1. So this is v prime. Okay, so now let us use the formula. So it's supposed to be u v prime plus v u prime. Okay, so this is equal to 1 over x cubed square root of 2x squared minus 1. So u times with v prime, so we got 2x to the power of 4 over the square root of 2x squared minus 1, and then plus with 3x squared multiply with the square root of 2x squared minus 1. Okay, so basically I'm gonna change my left hand side into a single fraction first, sebab yang sebelah sini dia ada fraction, ada yang tak ada fraction. So we're gonna simplify first. So 1 over x cubed, the square root of 2x squared minus 1, so that is equal to 2x to the power of 4 plus 3x squared multiply with 2x squared minus 1, and then divide everything with the square root of 2x squared minus 1. So kita samakan pembawah, so maksudnya saya tarik yang ni naik atas lah, saya darab dengan dia. Okay, so what happened now, I'm going to get 1 over x cubed the square root of 2x squared minus 1, and then I will have 2x to the power of 4, so 3x squared, 2x squared, so plus 6x to the power of 4 minus 3x squared over the square root of 2x squared minus 1. Okay, so let us simplify again. So x cubed square root 2x squared minus 1. Okay, so let's see. So 2x to the power of 4, 6x to the power of 4, so I have 8x to the power of 4 minus 3x squared over the square root of 2x squared minus 1. Okay, so I'm going to combine them. So I'm going to multiply the numerator and the denominator. Factorizing x to the power of 2, so I have 8x squared minus with 3 over x cubed and then 2x squared minus 1. Okay, so simplify them. So I will have 8x squared minus 3 over x together with 2x squared minus 1. Okay, so done with question number 2B. Okay, so let us proceed to C. Panjang ni. But I do think that it is quite long because I didn't simplify them straight away. Saya buat sikit-sikit, so sebab tu dia nampak macam panjang lah. But I'm sure if you do it all at once, dia nampak macam simple sikit. Okay, then with number 2B, number 2C now. Okay, so number 2C. So y is equal to cos x over 1 minus cos x. Hence, find dy over dx when x is equal to pi over 2. Okay, so number 2C, so we got y equal to cos x over 1 minus cos x. Okay, so I need to find dy over dx first. So obviously this is a fraction, right? So we're gonna use a quotient rule. So the top one will become a u, the bottom one will become a v. So v u prime minus u v prime over v squared. Okay, so let us differentiate. So dy over dx. V first, 1 minus cos x. Differentiating cos, it will give us negative sine x minus u cos of x. Differentiating 1 minus cos x, so it will become negative sine, so it will become positive sine of x over 1 minus cos x square. Okay, so let me simplify our numerator. So we got 1 times with negative sine x, so negative sine of x, negative, so this is a positive of cos x sine x minus cos x sin x. Oops. What happened? Sebab nak tulis kat tepi kot. Okay, let us move a little bit. Sin x over 1 minus cos x square. Okay, so you do simplify your numerator. So nampak benda yang boleh cancel kan, so kita cancel. Okay, so what we have left is simply negative sine of x over 1 minus cos x square. So when x, so it gives to us earlier that x is equal to pi over 2. So when x is equal to pi over 2, so dy over dx will be equal to negative sine pi over 2 over 1 minus cos pi over 2 and then square. So we need to find out what is the value then. Okay, so sine first. So I don't really have my calculator with me, so I need to sketch them. So the graph of the sine, so this is pi over 2, so this value is 1. So this is equal to 1. Cos pi over 2, So the graph looks something like this. So this is pi over 2, so the value is 0. Okay, so what do we have over there is negative 1 over 1 minus 0 square, which will give us the value of negative 1. Okay, so I'm done with question number 2C. So let us go to the last question on part A, which is question number 3. Okay, so let us read question number 3. The curve y equal to x squared minus 16 over x has stationary point P. Find the coordinate of point P. So we got a stationary point. So I might need to differentiate them. Okay, so question number 3. So y is equal to x squared minus 16 over x. So I have to differentiate them first. So this is dy over dx equal to differentiating x squared, it will become 2x. Differentiating this one, if you bring them up, we will have negative 16x to the power of negative 1. So bring the power down, so we have positive 16 over x squared. So to find the stationary point, we're going to let dy over dx equal to 0. So we will have 2x plus with 16 over x squared equal to 0. So I'm gonna bring 16x squared to the left hand side, or should we have a common denominator first? Common denominator first then. So 2x cubed plus with 16, so this is equal to 0. So 2x cubed is equal to negative 16, x cubed is equal to negative 8, x will be equal to the cube root of negative 8. So x will be equal to negative 2. Okay, so once we know the value of x, then we can actually find out what is the value of y. So y is equal to x cubed. X cubed or x squared? X squared. Oh, x squared. Okay. So negative 2 squared minus 16 over x. Okay. So minus 16 over x. So negative 2 squared is 4, negative 16, negative 2, so it will become positive 8. So this answer is actually 12. Therefore, P is negative 2, 12. So that is our stationary point. And we are done with part A. Congrats everyone. So let us go to part B. So sekejap, simplify sikit. Oops. Terpotong. Macam mana? Sekejap. Saya potong lagi sekali. Sana sikit. Okay. Okay. Right. Good then. Okay, so let us do question on part B. Okay, so question number 1A, given that z1 is equal to 1 plus 2i, z2 is 3 minus 4i, express 1 over z1 plus 1 over z1 minus 2z2 in the form of a plus bi, where a and b are real number. Okay, so 1 over z1 plus 1 over z1 minus 2z2. So this is 1 over z1 is 1 plus 2i plus 1 over 1 plus 2i minus 2 multiply with 3 minus 4i. Okay, so 1 over 1 plus 2i plus 1 over, so this one let me simplify, so 1 minus 6 negative 5, and then we got 2, 8, 8 plus 2, so this is positive 10i. Okay, so now there are two steps to solve them, two ways to solve them. Not two steps, there are two ways to solve them. So the first way is that you can choose to make sure you have a common denominator first. Common denominator. And then you can rationalize them later on. So make sure you have a common denominator, then you rationalize. So the second way is that you do the rationalize first and then the common denominator. So dia tengoklah kita nak buat yang mana satu. So dia boleh start dengan common denominator dulu baru rationalize, or you can do rationalize first before common denominator. So up to you. So for me, what should I choose? I think I better choose common denominator first and then rationalize. Okay, so I'm gonna have negative 5 plus 10i plus with 1 plus 2i over 1 plus 2i multiply with negative 5 plus with 10i. Okay, so what happened next? We're going to simplify our numerator. So we have negative 5, positive 1, so this is negative 4 plus with 12i over 1 times negative 5 plus 10i minus 10i, and then that one is positive 20i squared. Okay, so now be extra careful if you do see something that is higher than I, for example I square over here, so change this one to become negative 1. Okay, so what do we have in our numerator? So we are going to get negative 4 plus with 12i over, so negative 5, negative 20, so negative 25, and then 10i minus 10i cancel out lah, so kita tinggal benda ni je lah yang kita tutup kosong. Okay, so what do we have is actually 4 over 25 minus 12 over 25i. Okay, so I think that's it for question number 1A. So let us proceed to number 1B. Saya rasa macam ramai yang tak apa-apa nak boleh jawab number 1B. Okay, so there is a trick actually to solve them untuk number 1B tu. So I'll show you the trick later on. Nanti mesti macam aha moment tau, dia mesti macam oh itu je nak siap, tak ada payah sangat. Okay, so let us do question number 1B. Given that z is equal to x plus yi, where x and y are real numbers such that, okay, so number 1B, we have the modulus of z over z plus 2 minus I, and this is equal to 1 over 2. Okay, so basically this is actually a complex number. So the modulus of a complex number is not the same as what we learn in chapter 2. So kalau dekat chapter 2 absolute value tu kita boleh pecah jadi positif dengan negatif kan. Tapi kalau modulus untuk a complex number, this is actually the square root of a square plus b square. So ini adalah untuk complex number. So kita nampak dia ada huruf I, kita tahu ini adalah complex number lah. So kita akan menggunakan definition untuk modulus of a complex number. Okay, so I'm going to separate the modulus first. So I will have the modulus of z over the modulus of z plus 2 minus I equal to half, and then I'm going to bring the 2 up and this one up. So I will have 2 modulus of z equal to modulus of z plus 2 minus I. So now let us replace the z with x plus yi. So I have 2 modulus of x plus yi equal to x plus yi plus 2 minus I. Okay, so on the left hand side, this is fine. I'm gonna use the formula later on. But on the right hand side, I need to separate the real part and the imaginary part. So the real part is x plus 2. The imaginary part is y minus 1 I. Okay, so we're gonna use the definition now. So this is 2 times with the square root of x square plus y square, and this is equal to the square root of x plus 2 square plus y minus 1 square. Okay, and then we're gonna expand them. Okay, so get rid of the square root. So I have a 4 times with x square plus y square. And this is equal to x plus 2 square plus y minus 1 square. So expand this. So this is 4x square plus 4y square. So this one will become x square plus 4x plus 4 plus y square minus 2y plus with 1. So simplify a little bit. This is x square plus y square plus 4x minus 2y, 4 plus 1. So this is plus 5. Okay, so bring everything to the left hand side. So 4x square minus x square. So 3x square plus 3y square minus 4x plus 2y minus 5 equal to 0. And this is actually what we want to prove. So boleh tengok sekejap lagi lah. Sekejap saya kecilkan sikit, nanti kita boleh tengok dia sama saja. So we have e to the power of 2x minus e to the power of negative 2x over e to the power of 2x plus 2e negative 2x equal to 1 over 4. So this one, bring them up. Okay, so I will have 4 multiply with e to x minus e to the power of negative 2x. This is e to x plus 2e negative 2x. Okay, so this is 4e to x minus 4e negative 2x. So this is e to x plus 2e negative 2x. So bring them to the left hand side. So we got 3 e to x negative 4 negative 2. So it will become negative 6 e negative 2x equal to 0. So I'm gonna factorize the 3 out together with e to the power of negative 2x. So over here I will have e to the power of 4x minus with 2 equal to 0. So I do know that e to the power of negative 2x cannot be equal to 0. So that means e to the power of 4x minus 2 need to be equal to 0. Okay, so kenapa yang ini tak sama dengan kosong? Dia sebab eksponen, kalau kita lukis graf kan, graf dia sentiasa lebih besar daripada kosong. So nilai dia always greater than 0 untuk e to the power of anything lah. So it cannot be equal to 0. So that is how I know I don't have any solution for the first one. Sebab dia bila sama dengan kosong, kita kena ambil each factor, samakan dia dengan kosong. Okay, so I'm going to take the second one. So I have e 4x is equal to 2. So 4x is equal to ln of 2. Therefore x is simply equal to ln 2 over 4. Ataupun nak tulis 1 over 4 ln 2 pun boleh jugalah. So either one will do. Okay, so that is the answer for question number 2a. So let me proceed with the next one. Okay, so number 2b. Right, so the modulus of 3x plus 11 over x minus 3 is greater than 4. Find the solution set. So this question, they ask us for the solution set. So mesti kena guna solution set lah for the inequality. So firstly, I need to open the absolute value sign first. So using the definition, negative 4, 4. So greater than 4 or less than negative 4. So we will have two things. Either 3x plus 11 over x minus 3 is less than negative 4, or 3x plus 11 over x minus 3 will be greater than 4. Okay, so let me solve the left hand side first. Bring negative 4 to the right hand side. So 3x plus 11 over x minus 3 plus 4 less than 0. So 3x plus 11 plus 4x minus 12 over x minus 3 less than 0. So 3x, 4x, 7x minus 1 over x minus 3 less than 0. Okay, so now we're gonna do the real number line for this. So assume, or you can write down let, either one, 7x minus 1 to be greater than 0, x greater than 1 over 7. So just in case you forgot, normally for me, I always assume them to be greater than 0. So sometimes I have equal, so that one need to be referring to the question that we have before this. Okay, so normally for assume, I always assume them to be positive. Okay, the second one, we have x minus 3 greater than 0, so x will be greater than 3. Okay, so let us draw the number line then. Okay, so I have 1 over 7 over here, 3 over here. So starting from 1 over 7 to the right hand side, starting from 3 to the right hand side, I'm assuming them to be greater than 0. So on top of my line, I should write down a positive. Those without the line, it should be negative. So positive, negative, positive. And then referring back to the last ones, the last step before I assume I want the answer to be negative, so I should choose this one. So 1 over 7 and 3. So that is the answer on the left hand side. So now done with the left hand side, let me proceed to the right hand side. Okay, so we got 3x plus 11 over x minus 3 to be greater than 4. So bring it to the left hand side. So 3x plus 11 over x minus 3 minus 4 greater than 0. Okay, so this is 3x plus 11 minus 4x plus with 12 over x minus 3 greater than 0. 3x minus 4x, so negative x, 11, 12, so it will become positive 23 over x minus 3 greater than 0. Okay, so now let us do the assume part. Okay, so I'm gonna assume negative x plus with 23 to be greater than 0. Negative x is greater than negative 23. X will be less than positive 23. Be extra careful. We should flip the sign because we are dividing with negative 1. Okay, so now focus on our denominator. So we have x minus 3 greater than 0. X is greater than 3. So now the number line. So we got 3 here, 23 there. Okay, so 3 is greater than, going to the right hand side, less than, that means I'm going to the left hand side. We are assuming them to be positive, so on top of my line, everything should be positive. Those without the line, negative, so negative, positive, negative. Okay, so referring to the last fraction before I assume I want them to be positive, so my answer should be right in the middle. So this is 323. Okay, so I do have the answer on the left hand side and right hand side. So now we should combine them. So if you refer to the word that we write down, so we are saying it must be an OR. So OR means that I need to do a union between these two answers. So let us do the union then. So we got 1 over 7, 3, 23. So 1 over 7 until 3, 3 until 27. And union simply means everything below the graph. So my answer will be x such that x is in between 1 over 7, x 23, but x cannot be equal to 3. Okay, so now let us do question number 3. Okay, so given that fx is equal to negative 3 for x less than or equal to negative 1, x minus 2, x in between -1 and 4, 2 minus x minus 4 square for x greater than 4. Sketch the graph. Okay, so we need to sketch the graph. So I need to prepare the x and the y-axis. Awak ada pembaris kan? Nanti dia cantik je kan? Okay. So this is -1. So I'm supposed to get -3. So this is -3. And this one we have an equal sign. So a tangent all the way from -infinity up until -1. And then x minus 2 for x in between -1 and 4. So for me, I normally prefer to find out when x equal to -1, what is the value of fx. So I got -1, -2, so -3 then, so this is y. When x is equal to 4, I have 4 minus 2, which is equal to 2. So the first one is y equal to -3, so I'm starting at the same point. And then when x is equal to 4, I'm supposed to get positive 2. So this one is perhaps 2. We have the equal sign here. And then we need to make sure we meet them. So mari saya try lah. Kalau tak kena nanti awak guna pembaris lah. Boleh lah sengit sikit tapi tak apa. Okay, so 2 minus x minus 4 square. So this is actually a quadratic. So negative x minus 4 square plus 2. So yang ini kalau ikutkan dia punya maksimum adalah 42. So 42 is somewhere here. And then this is for x greater than 4. So sekejap, saya nak panjangkan sikit graf ni. So panjang sikit So this is x and something like this. Okay, so this is the graph. Okay, done with the sketching part. Okay, so now what else do we need to do? State the domain and range. Okay, so domain referring to the value of x. So I do see that the value of x is starting from here. So this is -infinity. And then we are going to x greater than 4. So this is up until infinity. So this is actually our domain. For the range, so we are seeing it should be greater than 4. Graf ni patut bawah lagi Okay, so tapi jangan sengit sangat. Tersengit pula. Dia macam pantul balik pula. Okay. Payahlah. Dia dah, apa orang kata, dah smooth tu kan. Tapi nanti tarik sikit lah. Bagi panjang sikit. Alah, halal lah tu. Malas lah nak padam. Okay, so the range correspond to the value of y. So we do have something for here. So my range always start from -infinity, and the highest point or the peak is actually at y equal to 2. So we stop at 2 then. So -infinity until infinity, -infinity up until 2. So that is P. Determine whether fx is one-to-one function or not. Give the reason for your answers. Okay, so in order to know whether is it one-to-one function or not, we have to test first. So let me do a line for this. Okay, so I need to test. So let me do a horizontal line test. So by doing a horizontal line test, so this line actually cuts at 2 points. So I do know this is definitely not one-to-one function. Okay, so now let us write down the wording part then. Okay, so by using horizontal line test, the line cuts at 2 points. Therefore, fx is not one-to-one function. Oh, by the way, I didn't label, right? This is for B, this is for C. Okay, so done with C as well. Okay, so let us do question number 4 now. Okay, function f and g are defined as follows. So fx is x plus 2 over x minus 4. Gx is 3x minus 2. If f composite with g is equal to 3, determine the value of x. Okay, so number 4a. So f composite with g. So this is equal to 3. So let us try to substitute g inside the f then. So g is 3x minus 2. So f of 3x minus 2. So this is equal to 3. So we got 3x minus 2 plus 2 over 3x minus 2 minus 4 equal to 3. So we got 3x over 3x minus 6 equal to 3. So let me bring it to the right hand side. So 3x is equal to 3 times 3, 9x. 3 times negative 6, so negative 18. So negative 6x is equal to negative 18. Therefore, x will be equal to 3. Okay, so that is the answer for question number 4. Okay, so let us proceed with the next one. Number 4b. Okay, group job. Okay, number 4b, show that the f inverse is equal to blah blah blah. State the domain and range. Okay, so we need to find the f inverse. So number 4b. Okay, so fx is equal to x plus 2 over x minus 4. So I'm gonna do f composite with f inverse, and this is equal to x. So f inverse of x plus 2 over f inverse of x minus 4 equal to x. So bring it to the right hand side. So f inverse of x plus 2 equal to x. F inverse of x minus 4x. So let me bring the f inverse to the left. So f inverse of x minus x, f inverse of x. So this is negative 4x, negative 2. F inverse of x. And then factorize, we are going to get 1 minus x equal to negative 4x, negative 2. So f inverse of x is simply equal to negative 4x, negative 2 over 1 minus x. So let me factorize negative 2 out. So I have 2 plus 1, 2x plus 1 over negative, so x minus 1. So cancel out the negative sign. So we will have 2x plus 1 over x minus 1. Okay, so that is simply what we want to show over here. So now let us state the range and the domain. Okay, so now the domain of f inverse. Okay, so if you refer to here, we got x minus 1 in our denominator. Therefore, x cannot be equal to 1. So the domain will be negative infinity up until 1, union with 1 up until infinity. So this is the domain of my f inverse. Meanwhile, the range of my f inverse, so this is actually equal to the domain of f. And the domain of f, if you refer to the f, x minus 4 in our denominator, so that means x cannot be equal to 4. So negative infinity up until 4, union with 4 up until infinity. So that is the domain as well as the range. Okay, so now let us do C then. So let me combine them together before we do the C part. Okay, so let us do the C. Okay, so C, find f square. So C, f square of x. So this is f composite with f of x. Okay, so f inside the f. So we are going to get x plus 2 over x minus 4 plus 2 over x plus 2 over x minus 4 minus 4. Okay, so let me have a common denominator for our numerator first. So x plus 2 times with x minus 4 over x minus 4 over, in our denominator, so we got x plus 2 minus 4 times with x minus 4 over x minus 4. Okay, so I'm gonna times with x minus 4 over x plus 2 minus 4x minus 4. So we're gonna simplify the fraction. So we are going to get x plus 2 x minus 4 over x plus 2 minus 4 x minus 4. Kalau rasa macam tak nampak, dekat sini ni fraction kan, yang saya buat ni fraction. So nanti kalau kata kita bahagi dengan a over b, nanti dia jadi darab b over a. So nanti saya akan cancel lah x minus 4 tu. So that is how I get the one that I wrote down. Okay, so now let me simplify this. So I have x plus 2x, so 3x, 2 minus 8, so this is negative 6 over x minus 4, so negative 3x, 2 plus with 16, so that is equal to 18. Okay, so I'm gonna factorize out the 3. So I have 3 x minus 2 over 3, 6 minus x. So cancel out. So we will have x minus 2 over 6 minus x. So this is actually our f square of x. Okay, done with question number 4. Let me proceed with question number 5. Okay, so now question number 5. Given that fx is x over x plus 1, x minus 3 squared, show that f has two vertical asymptotes and state its equation. Find the limit at infinity, deduce the equation of horizontal asymptote. Okay, so number 5a. So basically, if we want to know what is our vertical asymptote, we need to make sure our denominator equal to 0. So either x equal to negative 1 or x is equal to 3. So I don't know, this is actually my vertical asymptote, but to show this, I need to apply the limit. So firstly, let us calculate the limit of x approaches negative 1 of x over x plus 1 x minus 3 squared. Okay, so we need to approach from either positive or negative, from either the right hand side. So in order to check your vertical asymptote, you need to make sure when you are approaching negative 1, either from the right hand side or left hand side, we are going to get some infinity. So negative 1 on the left as well. Okay, so I'm going to substitute with x equal to negative 1. So I have negative 1 over negative 1 plus 1, so it will become 0. Negative 1, negative 3, so that is negative 4 with a square. So this is definitely infinity, I know for sure, because anything divided by 0 is always infinity. So this one, this is negative 1 over 0, negative 4 square, so this is also equal to infinity. So in order to know whether is it positive or negative infinity, I need to be extra careful with either I'm approaching from the right hand side or left hand side. So from the right hand side, so let us choose a number that is greater than negative 1. So perhaps negative 1 on the right hand side. So plus 0.1, let me use negative 0.9. So negative 0.9 plus 1, so this is a positive number. So negative, positive, positive, so this is a negative infinity. So negative 1 from the left hand side, so this is negative 1. On the left, perhaps negative 1.1. So negative 1.1 plus 1, so this is negative actually. So a negative number on top, negative number on the denominator. So this is definitely positive infinity. So from that, I know for sure that x equal to negative 1 is a vertical asymptote. So now let us test the other one. Okay, so we have a limit as x approaches 3 on the right hand side of x over x plus 1 x minus 3 square. So this is 3 over 3 plus 1, which is 4. 3 minus 3, so this is 0 square. Okay, so this is definitely infinity because we have a number divided by 0. And then another one is the limit for x approaches 3 on the left, x over x plus 1 x minus 3 square. So 3 over 4, 0 square. This is also infinity. So to test is it positive or negative, we need to test some value in. So 3 on the right hand side, I have to add 0.1. So perhaps trying 3.1 minus 3, so this is 0 with a plus. And then you square that number, so this is a positive number, positive, positive, positive. So everything will give out a positive infinity. So 3 from the left hand side, so I might want to try to substitute with 2.9. So 2.9 minus 3 is a negative number. So 0 with a negative, but if I square them, a negative number will become a positive. So positive, positive, positive. So that means everything will give out positive infinity. So this simply saying that x equal to 3 is a vertical asymptote. So that is for question number 5. Okay, so 5a, let me proceed to 5b. Okay, so this is A1, so now A2, 5A2. Okay, so find the limits at infinity. So I need to calculate the limit as x approaches positive infinity of x over x plus 1 x minus 3 square. And then the other one is the limit as x approaches negative infinity for x over x plus 1 x minus 3 square. Okay, so try to substitute with infinity first. You're gonna see that you will end up with infinity over infinity. So yang ini kalau kita ganti dapat infinity over infinity. The bottom one, that is also negative infinity over negative infinity. Okay, so that means I need to divide with the highest power of my denominator. So the highest power of my denominator, I got x times with x square. So the highest power is actually x cubed. So we should divide with x cubed. So on top and the bottom, we should divide with x cubed. Okay, never mind. I think I'll move this one first. So let us solve that one. Okay, so this one, this is the limit as x approaches positive infinity, x over x cubed over x plus 1 times with x minus 3 square over x cubed. Okay, so this is the limit as x approaches positive infinity, 1 over x square over, so we got x plus 1 x minus 3 square over x cubed. Okay, so now the reason why I didn't really expand them is that because I know when I do substitute with x equal to infinity, this term will give me a 0. So 0 divided by anything, So that is always 0, so this answer is definitely 0. Of course, you can actually expand them and simplify, but I just when I look at them, I don't think that I want to expand them, because I do know I will get a 0 in my numerator. It is a good thing for you to expand them first and see what happen. So boleh lah, kalau nak expand pun tak apa, tak ada masalah. Okay, so the same thing will happen in my x approaching negative infinity. So I'm gonna divide with x cubed, so x over x cubed over x plus 1, x minus 3 square over x cubed. So to try to expand them, so this is the limit for x approaches negative infinity, 1 over x square over x plus 1, x minus 3 square over x cubed. Okay, so again, I know for sure that my numerator will become 0. So the answer for this is equal to 0. Therefore, my horizontal asymptote is y equal to 0. Therefore, the horizontal asymptote is y equal to 0. So y equal to 0 is a horizontal asymptote. Okay, so that is 5A2. Okay, so now I'm done with 5A, so let us do 5B. A function f is defined by blah blah blah. Find the value of a such that the limit of x approaches 2 for fx exists. With this value of a, determine whether fx is continuous at x equal to 2. Okay, so now we said that the limit for x approaches 2 for fx exists. So 5b, it simply means that the limit for x approaches 2 on the left hand side must be equal to the limit as x approaches 2 on the right hand side. So the function is x minus 1 over x plus 2. This one is ax square minus 1. Okay, so substitute x with 2, 2 minus 1. So we got 1 over 4 equal to x square is 4, 4 times a, so 4a minus 1. So bring the 1 to the left. So we got 4a is equal to 1 over 4 plus 1, so 5 over 4. Therefore, a is simply equal to 5 over 16. Okay, so determine whether f is continuous at x equal to 2. So I need to calculate the limit first. Okay, so the limit for x approaches 2. So I'm gonna calculate from the left hand side. So I have x minus 1 over x plus 2. So this is actually equal to 1 over 4. So since the limit exists, I know that the limit for x approaching 2 for fx is equal to 1 over 4. So this is the second condition. The first condition, f of 2. So I'm going to substitute into ax square minus 1. So this is 5 over 16. X square, so 2 square minus 1. So this is 5 over 4 minus 1. This is also 1 over 4. So the third condition, I know for sure f of 2 is actually equal to the limit for x approaches 2 for fx. Therefore, fx is continuous at x equal to 2, definitely continuous lah. Okay, so done with this. Okay, so let us proceed with the next question. Yay, after this we got a differentiation question. My favorite, of course. Okay, so let us do question number 6. Okay, so let us start with 6a. if ey equal to 3x minus 4y, find dy over dx in terms of x and y. Hence show that, okay, so basically we have a second derivative over there. We need to prove it is equal to 0. Okay, so number 6a, so we got ey equal to 3x minus 4y. So do check your denominator. We have dx in our denominator, so I have to differentiate with respect to x. So d over dx of ey, d over dx of 3x minus d over dx of 4y. So basically, if we got a different variable, we need to use a chain rule. Same variable, we can straight away use the formula. Different variable again, so another chain rule. Okay, so let's see what happened. So differentiating exponent, this is ey times with dy over dx. So this is equal to 3 minus 4 dy over dx. So just in case you couldn't see how I use my chain rule, so let me show you one of them. So I'll show you for d over dx of 4y. So this one is going to be d over dy of 4y multiply with dy over dx. So that when you cancel out dy and dy, you're going to get d over dx of 4y again. And then differentiating 4y with respect to y, that is simply 4. And then you're going to times them with dy over dx. So that is how we get negative 4 dy over dx. So I'm going to bring it to the left hand side. So I will have ey plus 4 dy over dx. And this is equal to 3. So that means dy over dx is equal to 3 over ey plus with 4. So this is my dy over dx. Okay, so they want us to write them down in terms of x and y. So I'm going to replace ey. So this is 3 over ey is 3x minus 4y. And then we got another extra term plus 4. So this is dy over dx. Okay, so let us differentiate this to get the second derivative, because we have to prove them later on. So sekejap saya kecilkan sikit baru kita prove lah. Okay, so let us differentiate this again to get the second derivative. Okay, so let me choose dy over dx. So saya ambil yang sebelum tu lah. 3 ey plus 4 to the power of negative 1. Okay, so this is d2y over dx square equal to, so bring the power down, so we got negative 3 ey plus 4 to the power of negative 2. Differentiating ey plus 4, so it will become ey dy over dx. Okay, so what do we have is negative 3 ey dy over dx over ey plus 4 square, and this is actually equal to d2y over dx square. So I'm going to bring this to the left hand side. So ey plus 4 square d2y over dx square equal to negative 3 ey dy over dx. Okay, so let me substitute back. Ey is 3x minus 4y, so 3x minus 4y plus 4 square d2y over dx square equal to negative 3x minus 4y dy over dx. And let me bring it to the left hand side so that we can have a 0 on the right hand side. So this is 3x minus 4y plus 4 square d2y over dx square plus 3x minus 4y dy over dx equal to 0. Done, proven. Okay, so now let us answer number 6b. Okay, so number 6b. A curve has the parametric equation where t is a parameter. Show that blah blah blah. Okay, so the first one. Okay, number 6b. Okay, so x is equal to 1 plus t over 1 minus t. So obviously, if I want to differentiate this, I'm going to use some quotient rule. Okay, so dx over dt. So v first, 1 minus t, differentiating 1 plus t is 1 minus 1 plus t, differentiating 1 minus t is negative 1 over 1 minus t square. So this is 1 minus t, positive 1, positive t over 1 minus t square. Okay, so negative t, positive t will cancel out, 1 plus 1, so that it will become 2 over 1 minus t square. So now y is 2 over t square. Okay, so y is equal to 2 over t square. I'm going to bring them up. So y is 2t to the power of negative 2. So dy over dt, differentiating, bring the power down. So we got negative 4 t to the power of negative 3. Or we can say that dy over dt is actually negative 4 over t cubed. Okay, so now let us find out what is dy over dt. Dy over dx. Okay, so dy over dx. So this is dy over dt times with dt over dx. Okay, so dy over dt is negative 4 over t cubed multiply with 1 minus t square over 2. So cancel out. So you have negative 2. So we got negative 2, 1 minus t square over t cubed. Okay, so based on what we want to prove. Oh, saya dah buat sampai dy over dx lah. So actually I just need to prove dx over dt is 2 over 1 minus t square. So terlaju, tapi tak apalah. This is dx over dt equal to 2 over 1 minus t square. So yang ini dah jawab lah. Ini part B1. Laju sangat. Okay, and then differentiating dy over dx. So never mind, I already have dy over dx. I just need to differentiate them again. Okay, terlaju. Sabar je lah. Okay, let me differentiate that again to get d over dt of dy over dx. Okay, so d over dt of dy over dx. So that means I'm going to differentiate this again. So basically I'm going to use some quotient rule for them. So one of them is u, another one is v. So I'm going to differentiate them. So v first, so t cubed, differentiating negative 2, 1 minus t square. So I'm going to bring the power down. So I have negative 4. And then 1 minus t, deduct 1 to the power of 1. Differentiating 1 minus t, so negative 1 minus. So we got 2, 1 minus t square. Differentiating t cubed, it will become 3t square over. Okay, so t cubed square. Okay, so let me simplify this a little bit. Okay, so if I do see something in common, I'm gonna factorize out the term. Okay, so I do see 1 minus t here as well as here. So I'm gonna factorize 1 minus t. And then I do have something in common other than that. So I have t cubed and t square. So I'm gonna factorize t square. So I'll be left with t in front here. And then based on the constant, I have 4 and 2. So that means I can actually factorize the 2 out as well. Okay, so there are a few things to factorize, so do make sure we get them right. So firstly, the constant first, I'm going to bring the 2 out. So comparing t cubed and t square, I'm going to factorize t square out. And then I'm going to factorize 1 minus t. Then let us see what do we have inside here. So I already take out 2. That means over here I'll be left with negative 2. negative 2 times negative 1, it will become positive 2. So one of the t square has already go out, so I'll be left with another t, so 2t then. Over here, I already get rid of the 2, I already factorized the 2. I already factorized 1 of 1 minus t, so I'll be left with another 1 minus t. I already factorized t square, so I'll be left with 3 over t to the power of 6. So we got 2t square, 1 minus t. And then over here we got 2t minus 3t, so negative t. 1 times 3, so plus 3 over t to the power of 6. Okay, so now simplify them a little bit. T square, t6, so we can actually simplify them. So this is actually t to the power of 4. Okay, so what do we have is 2, 1 minus t, as well as 3 minus t over t to the power of 4. Okay, so let us check, do we have the similar thing with what we want to prove? 2, 3 minus t, 1 minus t, okay, and then we do have t to the power of 4, okay, very good. So we already have 5 marks in our hand. So that is for the second part. And then it said find the value of d2y over dx square at 0.38. So 38, it simply means that the value of x is equal to 3, the value of y is simply equal to 8. And then we need to find out what is the value for d2y over dx square. Okay, so firstly, let me calculate the second derivative first. So d2y over dx square, so this is actually equal to d over dt of dy over dx multiply with dt over dx. So I already have 2, 1 minus t, 3 minus t over t to the power of 4. So now I need to times with dt over dx. 2 over 1 minus t square. 2 over 1 minus t square. Okay, so 2 cancel out, so I will be left with 1 minus t cube, 3 minus t over t to the power of 4. Okay, so now let us see what is the value of t at 0.38. So I'm gonna choose the second one. So I have 1 plus t, so 1 plus t over 1 minus t equal to 3. So 1 plus t is equal to 3, 1 minus t. So I have 1 plus t equal to 3 minus 3t. So t plus 3t is 4t equal to 3 minus 1, which is 2. So t will be equal to 1 over 2. So I know that t is equal to half. So let us substitute into the formula of the second derivative. Okay, bring this one down. Okay, just in case you didn't know where this comes from, this is actually when x equal to 3. Okay, so now d2y over dx square, this is equal to 1 minus half cube, and then 3 minus half over half to the power of 4. Okay, so 1 minus half, so that is actually half to the power of 3. 3 minus half, so that is 6. So 5 over 2 over 1 over 2 to the power of 4. So if you simplify the power, you're going to end up with 5 over 2 over 1 over 2. So 5 over 2 times with 2 over 1. So cancel out the 2, we will be left with 5. So that is the answer for number 3. Number 6, B3. That's quite a long one, right? Okay, so I think we can do question number 7 now. But before that, let me do something with this first. So nanti dia hilang, nanti kita tak perasan. Okay, group this one. Okay, the last question. Oh, I am so excited to do the last one. Finally, we are at question number 7. Okay, let's see. I want to use another color. Perhaps a blue. A blue will look quite nice. Okay, so question number 7. A hollow right circular cone has a base of 5 cm and a height of 10 cm. A cylinder is inscribed in the cone such that the axis of the cone and cylinder coincide. Okay, so let us draw a cone. Okay, a cone. Kalau dia singit, nanti awak lukis lah guna awak punya ni. Apa maksud dia? The axis coincide. Maksudnya, okay, kat sini kan kita ada yang tengah-tengah ni kan. Okay, so nanti kalau kata kita lukis silinder tu kat dalam ni, dia punya tengah-tengah pun sama dengan cone kita jugalah. Jadilah. Okay lah tu. Cantik lah tu. Give up kadang-kadang. Okay, base dia 5. Okay, so sekejap saya nak buat base dia. So base dia 5, height dia 10. Okay, so let's see. Okay, 10. Right. Blah 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 blah. Okay, so now 7A. If the cylinder has a base of radius X, okay, so this cylinder radius is X and the H height is the H. Okay, sure that the volume of the cylinder is equal to that. Okay, so what is the formula for the volume? Volume of a cylinder, that is actually pi r square H. So this is pi. The radius, as you can see, the radius over here, this is x square, and the height is simply h. Okay, so what's the difference? So from here, I don't see anything with a h, so that means I definitely need to change the h. Okay, so I'm gonna draw a triangle involving them. Okay, let's see if I can draw them correct now. So dia nak right angle, so kalau pembaris tak ada, payah sikit. Rasa macam ada lah pembaris kat sini. Tak ada tak apalah. Oh tu sangat lah. Sekejap lah. Oh, cantik. Okay, good. Very good. Okay, so now what do I have here? This is 5, this is 10, sebab ini adalah triangle yang besar. Untuk kita punya cylinder, this is the X and this is the H. Okay, so I'm gonna compare the trigonometric ratio. So if this is the angle, so by trigonometric ratio, okay, so the opposite is 5, the adjacent is 10, equal to, okay, so the small triangle, so the opposite is X, the adjacent, so yang bawah ni kita panggil sebagai H, so that means this one is definitely 10 minus H. Okay, so I need to make sure I have h as the subject. So this is 1 over 2 equal to x over 10 minus h. So 10 minus h is equal to 2x. So h will be 10 minus 2x. So I'm gonna substitute the value in there. So v is equal to pi x square multiply with 10 minus 2x. So if you do factorize the 2 out, so you are going to get 2 pi x square 5 minus x, just like what they want over here. Okay, done. 3 marks. Find the maximum volume of the cylinder. So see, the question really got you right. So even if you couldn't show them, never mind, you can actually use this value to find the maximum volume. Okay, so to answer B, I have to find the stationary point first, and then I need to calculate the second derivative as well, because I need to prove I have a maximum volume. Okay, so let us differentiate this to get dv over dx. So this one I definitely need to use some product rule. So 2 pi x squared differentiating 5 minus x is negative 1 plus 5 minus x differentiating 2 pi x squared, so it will become 4 pi x. Okay, so what it will give us is negative 2 pi x squared and then plus 20 pi x minus 4 pi x squared. So this is dv over dx. Okay, so let me simplify this a little bit. So this is negative 6 pi x squared plus 20 pi x. Okay, so now let us calculate the second derivative straight away, d2v over dx squared. So this is negative 12 pi x plus 20 pi. Okay, so to find the stationary point, I have to let dv over dx equal to 0. So let dv over dx equal to 0. So negative 6 pi x squared plus with 20 pi x is equal to 0. So I'm going to factorize the x out as well as the 2. So 2x, so I got negative 3. Actually, the pi can go out as well, so let me factorize the pi outside as well. So I have 2 pi x, and this is negative 3x, and then plus with 10 equal to 0. So either x equal to 0 or negative 3x plus 10 is equal to 0. So x will be equal to 10 over 3. Okay, so now I need to know which one gonna give me a maximum volume. So we got to substitute into the second derivative. So when x is equal to 0, d2v over dx squared is equal to negative 12 pi times with 0 plus 20 pi. So this is actually equal to 20 pi, which is greater than 0. So this is definitely a minimum volume. Okay, so now the next one is that the x is equal to 10 over 3. So when x is equal to 10 over 3, so we got d2v over dx squared equal to negative 12 pi 10 over 3 plus with 20 pi. So this is 4, this is 1, so negative 40, positive 20, so this is negative 20 pi, which is less than 0. So this is the value that can give me a maximum. Okay, so the question asks for find the maximum volume of the cylinder. So that means I can substitute the value of x. So the formula for the volume is 2 pi x squared, and then is it 5 minus x? So let me check again. 2 pi x squared, 2 pi x squared, 5 minus x, yep. So now we're gonna replace the x with 10 over 3. So 2 pi 10 over 3 square 5 minus 10 over 3. Okay, so this is 2 pi and 100 over 9. This is 15, so this is 5 over 3. So what do we have is, oops, so 200 times with, so this is 1000 pi over 27. Okay, so this is our answer. So that is actually the maximum volume. Okay, so with that, I'm done with the second set. So I'll see you guys tomorrow.